So in this video, we're going to talk about how to add signed numbers using the idea of canceling, kind of like what we did with the chipboard. So again, let's start with the easiest kind of problem, 3 plus 7, which you know is 10. The idea is you can think of it as you have 3, you have another 3, you have another 7, together you have 10, right? If you were doing it on the chipboard, it would be, right, you have 3 chips, and you add another 1, 2, 3, 4, 5, 6, 7 chips, so you have a total of 10 chips. Okay, and similarly, if you have negative numbers, it works the same way. You owe 3 chips, or you owe $3, and then you owe another $7. Together you owe $10. And same thing with the chipboard. And that, if you use a chipboard, obviously you can put the chips right in, and that makes sense. If you don't use a chipboard, you can start thinking about things like 356 plus 247, and you can add them together using 356 plus 247, right? 13, 6, 10, 4, 603 equals 603. Or if you want to do that with negatives, it works exactly the same way. 356 plus 247 equals, negative 366 plus negative 247 equals negative 603. And we can do the same thing with fractions, right? Last video we talked about using 3/8 plus 5/6, and we saw in the last video, and if you want to go over that, you should watch the last video. That's the same as 9/24 plus 20/24, which was 29/24. Or if those were negative, it would be the same thing. Negative 9/24 plus 20/24 equals negative 20 equals negative 29/24. Okay, the trick, as always, is what happens when you start thinking about positives and negatives together, and that's when it gets tricky. So let's do a simple one. Let me just write this down so I have this for later. So 356 plus 247. Those are the ones that we were using. Okay, so if we have negative 3 plus positive 7, right? On the chipboard, when you thought about what that did on the chipboard, right? You had negative 3 and positive 7, 1, 2, 3, 4, 5, 6, 7. Remember what, 7? Yeah, thank you. Remember what you could do is you could put the pairs together, and we talked about them as forming 0. You can sort of think of them as canceling each other, and they go away, right? 0 doesn't mean anything, so these are all meaningless, right? And we end up with positive 4. Then these 3 pairs have kind of canceled each other and gone away. So the value would be 4, positive 4. Right, so let's see, so that would be positive 4. And we could do it with positive 3 and negative 7, right? You'd get 3 plus negative 7 would give you you'd get the cancellations, but since you have more negative chips than positive chips, then you would end up with a negative number. You would end up with negative 4. Okay. You could also think of it as owing, right? John owes $3. He has $7. His total account is $4. John has $3. He owes $7. His total account is negative $4. Now, what's happening is there's a piece here where you can match, right? If we're looking at, say, there we go. If we're looking at, say, 3 and negative 7, and we're trying to figure out what that is together, what's happening is that these 3 chips, right, since the 3 has a smaller absolute value than the 7, than the negative 7, these 3 chips are going to match with 3 of these chips, and so we're left with the difference, which is 7 minus 3, which equals 4, right? So that's how we know that this is negative 4. And we can use that technique for something like this, for 356 plus negative 247, right? We have to match the 247 here with 247 of this and figure out what's left over, right? If we owe $247 and we have $356, the difference is what we have, right? So we would subtract, using just regular subtraction and forgetting about the sign, 356 minus 247, right? That borrow, that becomes 16. I hope I do this right. 9, 0, and 1. So we're left with 109. So we've matched 247 from here. We've matched 247 from here. We're left with 109, and that's a positive 109. So that's going to be a positive number. So in other words, 356 plus negative 247 is positive 109. So take a minute and think about that for a second. I'm going to give you some bigger numbers to try. Why don't you try, let's see, 25. These are hard to do on the chipboard because they're too big. Plus negative 23, 100 plus negative 17, and let's do, actually that's fine. Take a pause, try those out. Okay, hopefully that you figured out that when you did that, you ended up with positive answers, right? So this would be 2, and this would be the difference between 117, which is 83. Let's reverse and make the larger absolute value negative. So negative 356 plus positive 247. So we're still going to match 247 with 247. But we're going to end up with 109, just like we did before, 109. But in this case, the 109s could be negative, right? Because we're matching the positive number with the negative number. We find out the difference between the two numbers, and we end up with negative 109 in that case. So let's try a couple of those. Again, numbers that aren't quite so big, but maybe a little bit harder. So how about negative 27 plus positive 18 and negative 53 plus positive 9. So take a pause, try those. So hopefully you figured out, right, if you match the 18 with the 27, right, you're left with 9, and that's a negative number. So this would equal negative 9. If you match the 9 with the 53, you're left with 44 here, and so that would be negative 44. And the same thing will work with fractions or any kind of rational number. So if I have negative 9 24ths plus positive 20 24ths, I have to recognize that this number has a bigger absolute value or higher magnitude. It's farther from 0. And so I'm going to match the 9 24ths with it and see what's left over. So to see what's left over, I have to remove 9 24ths from that. So 20 24ths plus, minus 9 24ths gives me 11 24ths. So my result is going to be a positive 11 24ths. If the situation were reversed and this were negative 20 24ths, and I'm adding that to positive 9 24ths, then a similar thing will happen. I'm matching the 9 24ths, I'm matching the 9 24ths with the 20 24ths. What's left over is going to be negative because this number has a larger absolute value. So again, 20/24 minus 9/24 is 11/24, and so my result here will be negative 11/24. So the basic idea is you're trying to match things up. So one way to think about this would be 9/24 plus, instead of 20/24, I think of it as splitting this up into negative 9, negative 9/24 plus negative 11/24, right? This together is the same as that. Okay, when I do that, I can basically know that these two cancel, like make a zero pair, and I'm left with negative 11/24. So think about that for a minute, and then I'll give you a couple to try. So why don't you try these? Let's see, negative 15/16 plus 3/16, negative 9/10 plus 12/10. Why don't you just try those, see what happens. Okay, so in this case, this is the larger absolute value. We can think about the difference between 15 and 3, which is 12. We can think about the 15/16 as negative 12/16 plus negative 3/16, right? Together, that's negative 15/16 plus, and then the positive 3/16. These cancel, right? And so we're left with negative 12/16, which reduces down. If you divide both by 4, you end up with negative 3/4. Over here, we have negative 9/10, and then 12/10 has a larger absolute value, so we can break that up into 3/10 and 9/10, to 9/10 plus 3/10 is equal to 12/10, right? But then the 9/10 cancel out, and our final answer is 3/10. So negative 9/10 plus 12/10 equals 3/10. So hopefully that gives you another strategy for adding signed numbers. So this is the cancellation strategy. You can use this strategy, or you can use the number line strategy. Either of them works pretty well.